Bismillahirrahmanirrahim. So I'm Muhammad Hakim bin Hussein, and with my two others group is Muhammad Haziq bin Muhammad Zaki, Faizah binti Mahmud. Today we're gonna talk about Faraday's law and its application. So we are from group 13. So what is Faraday's law? Okay, Faraday's law of electromagnetic induction refers to Faraday's law is a basic of electromagnetism predicting how a magnetic field will interact with an electric circuit to produce an electromotive force EMF. With this phenomenon is known as electromagnetic induction. Okay, Faraday's law states that a current will be inducted in conductor which is exposed to a charging magnetic field. Lenz's law of electromagnetic induction states that the direction of this induced current will be such that the magnetic field created by induced current opposes the initial changing magnetic field which produces it. The direction of this current flow can be determined using Fleming's right-hand rule. Okay, Faraday's law of induction explains the working principle of transformers, motors, generators, and inductors. The law is named after Michael Faraday, who performs an experiment with a magnet and coil. During Faraday's experiment, he discovered how EMF is induced in coil when the flux passing through the coil change. Okay, for the next part, I will pass to Muhammad Haziq bin Muhammad Zaki.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq bin Muhammad Zaki. I will continue with the next slide, which is the Faraday's first law. For your information, Faraday's law has two laws, which is first law and second law. Okay, for the first one, it says that any change in the magnetic field of a coil of wire will cause an EMF to be induced in the coil. This EMF induced is called induced EMF, and if the conductor circuit is closed, the current will also circulate through the circuit, and this current is called induced current. A method to change the magnetic field, the first is by moving a magnet towards or away from the coil. Second, by moving the coil into or out of the magnetic field. Third, by changing the area of coil placed in the magnetic field. Fourth, by rotating the coil relative to the magnet. Okay, for the second law, it states that the magnitude of EMF induced in the coil is equal to the rate of change of flux that linkage with the coil. The flux linkage of the coil is the product of the number of turns in the coil and flux associated with the coil. Okay, for the Faraday law formula, consider a magnet is approaching toward a coil. This is the example. Here we can consider two instants at t1 and time t2. Okay, according to Faraday's law of electromagnetic induction, the rate of change of flux linkage is equal to induced EMF. This is the formula. Uh, Consider Lenz's law where flux in WB is BA, the B represent for magnetic field strength and the A is area of coil. Okay.
Assalamualaikum and hi. Um, for application of Faraday's law is the one of the most basic and important law of electromagnetism. So, this law finds its application in the most of the electrical machines, industry, and the medical field, and others. Okay. Power transformers function based on the Faraday's law. The basic working principle of the electrical generator is Faraday's law of mutual induction. The induction cooker is the fastest way of cooking, and it also works on the principles of mutual induction when the current flows through the coil of copper wire that placed below a cooking container it produces a changing of magnetic fields. Okay, this alternating or changing magnetic field induces an EMF, and the current in the conductive container, and we know that the flow of the current always produces heat in it. Okay, so electromagnetic flow meter is used to measure the velocity of certain fluids. When a magnetic field is applied to an electrically insulated pipe in which conductive fluids are flowing, then, according to Faraday's law, an electromotive force is induced in it. This induced EMF is proportional to the velocity of fluid flowing. Okay? From base of electromagnetic theory, Faraday's idea of lines of force is used in well-known Maxwell equations. According to Faraday's law, change in the magnetic field gives rise to change in the electric field, and the converse of this is used in the Maxwell equations. It is also used in the musical instruments such as electric guitar, electric violin. Okay, so as a conclusion, any change in the magnetic environment of a coil or wire will cause a voltage (EMF) to be induced in the coil. No matter how the charge is produced, the voltage will be generated. The change could be produced by changing the magnetic field strength, moving a magnet toward or away from away from the coil, moving the coil into or out of magnetic field, rotating the coil relative to the magnet. Faraday's law is a fundamental relationship which comes from Maxwell's equation. It serves as transient summary of the ways a voltage or EMF may be generated by changing magnetic environment. The induced EMF in a coil is equal to the negative of the rate of change of magnetic flux times the number of turns in the coil. It involves the interaction of charge with magnetic field. That's all from our group. Thank you for listening our presentation.